Today I'd like to talk to you about feedback LEDs on when we're using the KNX TAP-5 coupler in independent button mode. So the first thing we need to do is change the operating mode to 5 independent buttons. We then have all of the different buttons on the left here. So let's look at top left. So in a previous video we've looked at kind of all the different function types, etc. But the status feedback LEDs are pretty much the same for all the various different functions. So we thought we'd do a separate video just on the status feedback LEDs. So behavior, the default is status indication. So depending on what function is selected, the status indication is slightly different. But for the case of switching, this basically, the status indication will follow the status of the effectively the group object output, the 1-bit output. So in the case of switching, when the light gets toggled on, the LED will get toggled on, and when the light gets toggled off, the LED will turn off. That includes if the group object receives a 1-bit telegram from another device that's sent it onto the bus. Maybe you had 2 keypads in the room. On the switching outputs, the write flag is enabled, so that would receive a telegram from another device and then update that LED to be turned off as well. So that's what the status indication does. For the case of the other functions, they are slightly different, but for simplicity, we just stick with switching. You've also got another option here, which is turn on during touch. So that's basically there just to ensure that you get like a really rapid response from the feedback LED when you touch the button. So what we're basically saying there is, do you want the LED to turn on when you touch the button, as well as a status, if that makes sense. So this just ensures a really smooth user experience, basically. So let's have a look at the other behavior options. So we've got spoken about status indication already. We have inverted status indication, which is exactly what it says on the tin. It's just the inverse of the status indication. So when the light is off, so when the light is on, the LED is off. So this could be useful in some instances where the device requires a 0 to turn it on. The other option here is if you just want the LED permanently on. So yeah, there might be instances where you just want that feedback LED on that particular corner just to be always on. So that gives you an option there, or always off. Or you might want to control that LED via a separate object. So you might not want that LED to be slave necessarily to the 1-bit object that is turning the light on and off. You might want to control that completely separately for some reason. So let's have a look at the control via separate object options. So you can control it using multiple different object types. So the default is 1-bit, obviously, because that's nice and simple. Light, LED light on, LED light off. So when you enable this option, you can see in the group objects here at the top left, we've got a 1-bit LED control input, which simply turns the light LED on and off. You can, instead of just being 1 is on and 0 is off, you can also invert that, or you can optionally set that LED to flash with a 1 and turn off with a 0. So there's some nice options there for 1-bit direct control of the LED. The other option is a 1 times 3 bytes object. So they're RGB LEDs. So you can actually directly control that with a RGB data point type. So that's one option. Or you can also control them via 4 1-byte objects. So that's RGBW. So in this instance, you actually end up with the red, the green, the blue, and the white as separate 1 bytes to control each individual channel of the LED, basically. So they're RGBW LEDs inside our keypads. The HVAC operating mode, so this is just a nice feature if you are using the keypad, or you want the LEDs around the keypad to reflect the HVAC mode of the room at that particular point in time. We have a HVAC data point type here, and you can specify for all of the different HVAC modes a color. So that's quite a nice option as well. And we've also got some threshold kind of controls. So if the in this instance it's 1 byte signed. So if the 1 byte signed value received is less than the threshold, greater than the threshold, equal to the threshold, etc., then the LED will turn off. Else it will turn on. Else it will turn off. So if it's equal to the threshold of 6, for example, the LED will turn on. Otherwise, the LED will be off. So again, some nice options there. Maybe if you had a humidity sensor in the room and you wanted the LEDs to turn on when the humidity was too high, for example, that's one example of how you could use this kind of threshold analysis to be able to control the LEDs. So yeah, there we have it. Lots of different ways of controlling the LED, either by the actual status of the function that the LED is kind of related to, or you can control via separate objects, and you've got lots of different objects there to control, or options to control it with. The 4 outside buttons, they all have individual LEDs that are associated with them. The center button doesn't necessarily have its own dedicated feedback LED, although we do have the option here to basically turn on during touch. So we can, when we touch the middle button, we can optionally override all the outside 4 feedback LEDs with a certain color. And that just gives us a nice option to kind of add some visual feedback to that middle button, even though it doesn't have its own dedicated feedback LED. Hope that is useful. If you've got any questions, then please let me know. Thanks.